Hi guys, today we're going to be looking at dividing radicals. Division really just is going to look like a bunch of fractions. So the main idea is that when you have a fraction that contains a radical, actually no, this is not an example, but when you have a fraction that contains a radical, you have two possible scenarios. You can have the radical in the numerator, or you can have the radical in the denominator. So the rule is it's okay to have a radical in the numerator. That would be considered totally simplified. However, it is not okay to have a radical in the denominator. Your denominator is irrational, and that's not all right to divide by an irrational denominator. So what you need to do is you need to rationalize the denominator. Rationalize the denominator. And we do that by using this fact that we've been using, which is that the square root of any number, like the square root of a times the square root of that number, is equal to that number, that whole number, the rational version of that number. So for example, the square root of 3 times the square root of 3 is just 3, right? Because the square root of 9 is 3. So we use that to our advantage to help us rationalize denominators. So in the example that I gave you first, that can be our first example, 5 over radical 2 is not simplified. So what you do is you say, well, I want to multiply the denominator by radical 2, because that would produce a rational 2. But if I do that, then I also have to multiply the numerator by radical 2, so that way I'm really multiplying by 1. Right? Any number divided by itself is really equal to 1. And so therefore I haven't changed the fraction at all. And so when I multiply the numerator by radical 2, I end up with 5 radical 2 over 2. And that's it. That can't be simplified. A rational 2 cannot be simplified with the square root of 2. They don't have any common factors. Okay, so we'll look at another one like this. Example 2. We're going to simplify 3 over the square root of 3. So I go straight to the denominator, and I see that it has an irrational number, so I multiply by the square root of 3 over the square root of 3. So that's going to give me, in the denominator, it gives me 3. In the numerator, I have 3 times the square root of 3, which is 3 times the square root of 3. Now, I'm allowed to simplify rational numbers with rational numbers. So 3 and 3 have a common factor of 3. So my final answer is just the square root of 3. So radicals can simplify with radicals and rationals with rationals. Okay, we'll take a look at another one. Example 3. 2 radical 5 divided by radical 6. So you go to your denominator, you say you cannot be their square root of 6, so you multiply by the square root of 6. And then you multiply the numerator also by the square root of 6, so that way you're really just multiplying by 1. And when you multiply the denominators, you get just regular 6. In the numerator, I have 2 times the square root of 30. Now I look to see if I could simplify, and the rational numbers, meaning the numbers that don't have a radical, they can be simplified together. So 2 goes into itself once, it goes into 6 3 times. My final answer is the square root of 30 over 3. This cannot be simplified. The square root of 30 is an irrational decimal, and 3 doesn't go into it. Done. Okay. We're going to look at some examples that are where our numerator contains a binomial. So for instance, example 4. You might have the square root of 3 plus 3 times the square root of 5 all over 2 radical 8. So as I look at my denominator, one thing that I notice is that the square root of 8 can be simplified. It contains a perfect square. So if you want, you don't have to do it this way, but if you want, you could rewrite this. So 8 is really 4 times 2. The square root of 4 is 2. So the denominator is really 4 radical 2. And that could just help you along so that you don't have to simplify it as much at the end. So what I usually like to do is I like to simplify it first. So I end up with 4 radical 2. Now, to rationalize this denominator, I just need to multiply by radical 2 over radical 2. Because the 4 is already rational. I just need to make the square root of 2 rational also. So when I do that, I end up with a denominator of 4 times 2, which is 8. Right, because the square root of 2 times the square root of 2 is 2 times the 4. And then I'm going to distribute. So remember, there's invisible parentheses in the numerator. I'm going to distribute my square root of 2 to both terms. So I'll have the square root of 6 plus 3 times the square root of 10. And I look to see if this can be simplified, and I see that it cannot. The square root of 6 and the square root of 10 are irrational, whereas 8 is rational. So I leave it like that. Now, some rules for simplifying I wanted to go over with you guys. Some rules for simplifying. I have to slide this up. Or get it, yeah. Okay. Rules for simplifying. If you have a situation where at the end of the problem you end up with something like 6 radical 10 plus 2 all divided by 2, and you need to simplify that, you can simplify this rational 2 only if it goes into both terms here. Okay, and the reason is because you're basically taking out a common factor. There's a parentheses here for both terms. So 2 goes into itself once, it goes into 6 3 times, and it goes into 2 once. So my final answer for something like this would be 3 radical 10 plus 1 all over 1, which I don't need to show. So just leave it as 3 radical 10 plus 1. Okay, here's another one. If I had something like 6 radical 10 plus 5 all over 2, this can't be simplified. Because even though 2 goes into 6, it doesn't go into 5. This 2 has to go into both terms in the numerator. It has to be a common factor to both terms in the numerator. And so therefore, this would be my final answer. Okay, so you'll come across some like this, some where you can simplify, some where you can't on the homework. You're going to do a couple of these for homework tonight, and we'll talk about it in class also. All right, thanks.